might not look exactly like the answer, but how many of you see the answer from this expression? Okay, a few of you. If you use factoring, I've got something times n plus 1 over 2 plus something else times n plus 1 over 2.
What'd you do to get between those two steps?
So you get the left-hand side?
Yeah.
Okay, the right-hand side, I multiplied and divided this by 2. This is the same. This I multiplied and divided by 2.
Just for the acronym?
Yes, for the fun of it. That's right. Acronyms are the goodest. Okay, now I've got something times n plus 1 over 2 times some other thing times n plus 1 over 2. How does factorings work from like middle school or whatever? Yeah. Ben.
You can turn it into n plus unit n plus 2 times unit n plus 1 all over 2.
Yeah, so you're going to factor this into n plus 2 times n plus 1 over 2, which is, oh my gosh, the sum as j goes from 1 to n plus 1 of j equals, I'm going to rewrite this as n plus 1 times n plus 1 plus 1 over 2, which is precisely p of n plus 1. So it's not just that we asserted p of n, and then we asserted p of n plus 1. We asserted p of n and showed that that implied p of n plus 1. Okay? To finish this, and this is something that I prefer, in this little corner here, right, therefore, we're done by induction. And then you get to color in your little box. This little note, therefore we're done by induction, just signifies to me that you understand that there is an argument here, and it's more than just, okay, I did that chunk, and I did that chunk, and now I'm putting my hand out for my points. This is an argument. We'll talk more about this argument style on Tuesday. A proof of mathematical induction is to say, here's a base case, here's a starting point, and this statement holds for my starting point. And then if any piece of it's true, if any p of n is true, then it will imply that p of n plus 1 is true. So if p of 1, I just showed p of 1 is true, and that, if I look at that thing and set n equal to 1, that means p of 1 implies p of 2, which means p of 2 is true. But because of that, p of 2 implies p of 3, which means p of 3 is true, and p of 4 is true, etc. So it goes all the way off to infinity. So we just proved an infinite number of statements, that is, we proved this for all natural numbers n. All right, thank you guys for putting up with me today. I'll see you on Tuesday. Have a good weekend. Oh, finish your 131 homework if you haven't. Oh my God.